Hello everyone, this is Dr. Young here, and today we are going to be talking about the Gabriel synthesis, which is a great way to make primary amines. Now, again, in this big old mix of reactions that we're going to be covering here, right? So this video is just about Gabriel synthesis and the use of thalidomide to make primary amines. That's what we're focusing, right? Previous videos talked about the reduction of amides and the reduction of amides and reductions of nitriles, and we'll get to the other ones later. Now, in those other videos, right, when we're talking about the reactions of amines, if I wanted to make this propylamine here, so propylamine, it's not unreasonable, right, to say, well, if I want to make propylamine, all I need to do is take propyl bromide, which is what we have here, and then just add ammonia and do my good old SN2 attack. Right, boom, boom. And it's not that you're not going to make propylamine, you will, but if you want to remember that the problem here is that unless you're really careful and use a huge excess of ammonia, you're going to end up having your propylamine go out and attack some of this propyl bromide, right, some of your starting material here, and then you're going to end up getting these multiple alkylations where this can just kind of keep on going. That's a terrible zigzag here. Come on. It's really funny. For some reason, I'm worse at zigzagging left than right. Probably just practice. Anyways, so then you'd end up with this, right? I won't do all of them. I've already talked about the polyalkylation problem. But the idea here is that you're going to end up getting a mixture of different amines. Right? You're going to get a mixture of different amines, not just the propylamine you want. And so that's the big issue here, is that we will get a mixture. And that might not be that big of a deal if, propyl bromide is cheap. You can just clean it up using a column or something like that. But if your alkyl group is something special, you spend a lot of time making, it's not cheap, it is expensive, it took a lot of time to make, you don't want to just waste a bunch of it doing this reaction. Which is why we have the Gabriel synthesis, right? Gabriel synthesis is great for making primary amines. This is your only amine product. There is no polyalkylation here. All right, if I want to make this propylamine, I can take this molecule over here called thalidomide, and that's this pH, TH. I can take this thalidomide, add just sodium hydroxide, add the propylbromine, and then add a hydrazine or do a hydrolysis, and I'm going to get that amine. So let's take a little closer look at exactly what this Gabriel synthesis is. Like I said before, right, the issues here is that you can only make primary amines, and the substituent must be a good SN2 substrate. You have to be able to do an SN2 reaction. You need to do that backside attack. So secondary and tertiary alkyl halides are probably out. Secondaries maybe, but you could get some elimination product too. The steps for this, right? First step is that you're going to use a base to deprotonate. This base just needs to be a strong base. It doesn't have to be super strong, so we just need something like hydroxide or better. You could use LDA or something like that. Sometimes you'll see NaH with these, but hydroxide works fine, which is what I have here, right? I've just got sodium hydroxide. And the idea is that hydroxide is going to simply deprotonate the hydrogen from this nitrogen, which is relatively easy to do because, as you're going to see, it's really resonance stabilized, right? It's like an amide, only there's two, so it's an imide or an imide, where this is resonance stabilized. Like I said, you can have the nitrogen go up into either one of the carbonyls. I'll draw one of the resonance structures here. And then, of course, you could have the lone pair delocalized onto the bottom carbonyl also, right? So it's delocalized. It's a really, really stable, this is a very acidic hydrogen. That sucker is acidic, so it's pretty easy to remove. But once you do that, now that nitrogen, right, now that nitrogen is nucleophilic. Right, it's now nucleophilic, but it's already got two groups on there, right? It's already a secondary carbon. And so what happens is that we can add our next step, right, the propylbromine, and I'll do that in blue, right? So step 2 here, I can add the propylbromine. And what happens is that the nitrogen then can do our SN2, right? And so that's why it's important that your substrates can do an SN2 reaction, because that's what we're doing here. This is just an SN2 step, attack from the backside, and you end up adding your propyl group onto that nitrogen. And in this case, we just have bromide. So you've made your, you've added a propyl group onto that nitrogen. Now, what you may remember from our carboxylic acid derivative chapter, right, is that this looks basically like an amide. And I know that I can do addition-elimination reactions with amides. I can have things add into that carbonyl, stuff kicks down, you can kick something out. And the same thing is going to be true for these imides, right, this thalidomide. What I have for the second step, let me write this here, right? So blue stuff was propyl. For this third step here, I have hydrazine. That's one possible thing that you could add. The idea is that if you add hydrazine, it will substitute out that nitrogen and add into your thalidomide. And I'm not going to go through the whole mechanism here. I honestly don't really care. It's going to look a lot like if you're making an amide, right? You'd have your hydrazine attack this carbon, these kick up, they kick down, kick out the nitrogen, etc., etc. Or you can do a hydrolysis, right? So you can add hydrazine, which I said is H2N, NH2, or you can do a hydrolysis reaction, right? So like H3O plus in heat, or we said step 1, NaOH, step 2, some sort of acid workup, right? The acid catalyzed or the base mediated. Either of those works, that all works fine. But what you're going to see here, right, the whole point of this step is to kind of free that amine, to get it, to remove it from this molecule. So now you've got your amine. It's picked up hydrogens from things. And like I said, your hydrazine in this case basically replaced it. I'll show you some other examples with the hydrolysis in the future, but the point here is that you've made a primary amine. And just the primary amine. There is no secondary amine that you formed. At no place could you form a secondary or tertiary. So this tends to be your main product, which is, again, the sort of bread and butter of the Gabriel synthesis. It's making primary amines. So some possible amine targets here, right? You just got to look through and see, well, what type of amines are these? So if I look at this first one is a primary amine, so that would work. Here, this is a secondary amine, so nope. This is a tertiary amine, definitely not. This is a primary amine. That would be a good SN2 substrate. And this is also a primary amine, but cannot do SN2 reactions. Cannot do SN2 reactions, right? Because it's on a phenyl ring. That's sp2 hybridized right here. No backside attack, stronger bond. Not the same mechanism at all. So I can't just substitute out that nitrogen. So really, this would possibly work, or that would possibly work. And again, if I wanted to make, let's say I wanted to make this one. If I wanted to make that, I would say, okay, well, I'm going to start with thalidomide. And I'm going to add some sort of strong base. So I'll do NaH in this example. And my second step is going to be to add whatever piece I want, whatever carbon piece. So I want a benzyl group. And I'm just going to slap a good leaving group on there. Let's just say it's a triflate, for example. And then for my third step, let's do H3O plus and heat so that we hydrolyze that thing at the end. So what I would expect to get then is this main piece, only if I do a hydrolysis, right, instead of amides, now I'm going to have carboxylic acids. and I should have my amine, right? So now that carbon group that I wanted to add should have an NH2 attached to it, right? Where this nitrogen here is this nitrogen here. And I'm going to show you some examples coming up. So here's 4. Not a bad idea to go ahead and pause here, take a look at this, do some practice, and I'll come back in just 1 second to make sure that we're on the same page. All right, so let's take a look at these, right? They all have the basic formula. For this first one, looks like I've got a base, check. Looks like this is the carbon piece that I want to add to my nitrogen. Great, so I'm just going to take my nitrogen, H2N, and it looks like I'm adding a 3 carbon piece, 1, 2, 3, with the alkene at the end. Perfect. And I don't need to draw this whole other thing. I'm not interested in that. It was a hydrolysis reaction, so I know that it was hydrolyzed to the phthalic acid. But I don't really care if you all show me that, because the point is to make amines, so I want to see the amine product. For this second one, similar thing. I've got a base. I've got benzyl bromide. So BN, remember, stands for benzyl, which is this piece. Oh, this is like the example I just did. So benzyl bromide. And then it looks like these steps are also the hydrolysis. This is the base mediated. So it's the same thing, those same 2 steps, right? Base, then acid. Going to give me the same sort of product here. I'm going to get a nitrogen, and then it's going to be on that benzyl piece. And again, I'd get the same phthalic acid as my side product. Now for these last 2, it's just asking you, well, what reagents do I need to add? And so you can do these a couple of different ways, right? The leaving groups can be different. The base you use at the very beginning can be different, and how you free that amine at the end can be different. So for this first one, let's just say I'm going to use, let's use LDA, even though that's probably overkill, but just to show you a different base, right? I just need something to take off this H. And then for step 2 here, looks like I need this cyclohexyl piece and 1 carbon. And then I'll just put on like a bromine or something, right? So I've got this cyclohexyl with a methyl piece. And then last step, let's do the hydrazine. That should give me that amine. And right, again, there's no reason I picked hydrazine. It could have been a hydrolysis reaction instead. Would have been fine. No reason I picked bromine. It could have been, iodine or tosylate or something else. And then for this very last one, let's use NaOH. Step 2, looks like I've got this friend here. And I'm just going to slap let's do a tosylate, OTS, right? That's a good SN2 substrate. And then step 3, let's do the H3O+ to free that amine. That would work. That would make that primary amine. So again, I hope that gives you a little better sense of what the Gabriel synthesis is. Definitely practice this stuff. Let me know if you have any questions. The key thing here is that it's easy to spot, right? Because it always has that same starting material. It's very unique. Easy to spot, and it makes primary amines. Really good for that. So study up, practice. Good luck.